Chapter 7 Estimation. So we'll do this past year questions now. A random sample of size n is taken from an exponential distribution with parameter lambda, that is with probability density function fx is equals to lambda e to the power minus lambda x for 0 less than x less than infinity. Determine the maximum likelihood estimate of lambda. Claim sizes of certain policies are modeled using an exponential distribution with claim parameter lambda. A random sample of such claim results in the value of MLE of lambda as lambda hat is equal to 0.00124. A large claim is defined as 1 greater than 4000 and the claim manager is particularly interested in P. The probability of claim that is a large claim. Determine P hat, the MLE of P, explaining why it is an MLE. So we'll start with the first part. So let's say writing question 1. And I have the examiner report open, so just follow the examiner report to show you all how to write. So part 1, alt equals to, so see this has been coming here, so what we'll do is change to, this always has to be left, okay, keep sure that this is left. So L of lambda, so this is how you write lambda backslash lambda, this we have done a lot of times. And then we need to write product, so PROD, see product of backslash lambda e to the power minus lambda x underscore I. So this completes this. Next line you can come write alt equals to we have backslash lambda to the power n e to the power minus backslash lambda, and then we have a summation of xi sign. So backslash sum x underscore I brackets close space. So e to the power minus lambda summation xi, and then taking log we have log of L backslash lambda space come out of the highlighted region is equals to n log lambda minus lambda summation x underscore I. Okay, next line alt equals to differentiating d by d lambda of, now I'll not write, I'll just copy this log L lambda is equal to n by lambda. So see, since I did not give a backspace, it did not turn into, so this is important, giving backspace, n by lambda. Otherwise if you don't even give lambda, that is also okay, both will be accepted. Okay, so even if you forget giving backspace, doesn't matter, it should be readable. Okay, summation xi, and then you write equate to 0 for MLE. So therefore alt equals to backslash lambda backslash hat 2 times space. So this becomes lambda hat is equals to 1 n by, then we write backslash sum space capital X underscore I space brackets close. So there was a by also here. Okay, and give space. N by summation xi is equals to 1 by x bar. So how will you write x bar space space space? So this becomes 1 by x bar. Okay, second derivative to check, they have not done but we will do. So d square by d lambda square, you don't have to write it again, you could have just copied, okay, from above and just put a square sign. So d square by d lambda square, and if you see this, what will this become? We are differentiating with respect to lambda. Since there is no lambda here, this will be nothing, this is a constant, and then here will become minus n by lambda square. So this is, since this is less than 0, so second derivative is less than 0, hence maximum. Okay, so this we have done. And then coming to part 2. Part 2 we have, my settings have changed a bit, we'll just change it to left again. We have P is equals to probability of X greater than 4000, which is equals to EXP of minus of 4000 divided by lambda. Okay, so this is there for exponential distribution. You could have written e to the power also. So alt equals to, therefore, you can give therefore sign also, you can just write therefore also, anything works. P hat is equals to e to the power minus 4000 lambda hat. Okay, using the invariance property of Emily. The theory part I am not writing, please write it. You have to write why have you put this. Hence this is equals to P hat is equals to e to the power minus of 4000 into 0.00124. Okay, so which is leads to equals to 0.0070. Okay, this is the basic part. So this completes question 1. Now coming to question 2. So we'll do this in a new page. For this also I am using a past year question paper. So these are the past year questions paper. A random sample of size n is taken from a gamma distribution with parameters alpha equals to 8 and lambda equals to 1 by theta. Question 2, sorry. The sample mean is x bar and theta is to be estimated. Determine the method of moments estimator MME of theta. So we need to find the method of moments estimator. So part 1. First writing, it's a gamma distribution. The expectation of x is equals to alpha by lambda. Okay, given alpha is equals to 8, lambda is equals to given this lambda is equals to 1 by theta. So here in examiner report they have skipped steps, but you cannot obviously skip steps, so I'm just writing all the steps for you. Therefore expectation of x is equals to 8 into theta. Okay, so this is there. This is the expectation of x. Therefore ME is equals to alt equals to x bar, since expectation of x is given to us, divided by 8. Okay, coming to second part, find the bias of MME determined in part 1. So we need to find the bias. So part 2, alt equals to expectation of x bar divided by 8 minus backslash of theta is equals to 0. Unbiased, we have to find the biased estimator. So firstly expectation of x bar by 8. Okay, I missed out the first line, sorry. Expectation of x bar by 8 is equals to 1 by 8 into expectation of x bar, which is equals to 1 by 8 into 8 theta okay, is equals to theta. Okay, and for bias, expectation of x bar divided by 8 minus theta is equals to 0. Hence MME is unbiased estimator of theta. Okay. Next is determine the mean square error of the MME of theta. So we need to find the mean square error of MME of theta, which is 3. Then you write part A. For 3 part A, we have MME is unbiased. Therefore, MSC is equals to MSC of x bar divided by theta is equals to variance of x bar by theta, which is equals to 8 theta square divided by 64n, which is equals to theta square divided by 8n. Okay, so this is our part A. And part B is MME gets more. What is they asked? Comment on the efficiency of MME of theta based on your answer in part 3A. So MME will get more efficient as n obviously increase as sample size gets smaller. MSC gets smaller. So MSC gets more efficient. This is sheer theory. I'm just writing it for you all. Increases. Okay, so this is your point estimation where we covered MLE also and point estimation also. Thank you.